Okay, in this video we're going to be talking about formula manipulation. Being able to manipulate equations is one of the most important skills to master and to succeed in high school science courses. And so really all that we mean by manipulating formulas or formula manipulation is that we are rearranging an equation to isolate and solve for an unknown variable that you're trying to calculate. So this is something that you have already learned in math, and this is something that is also going to come up here in science courses. And there's two basic rules from algebra about how to manipulate formulas. So I'm going to go over these two basic rules and then go through a couple of examples. So first of all, if you want to move something to the other side of an equation, then you have to do the opposite math operation to it. So for example, if we had a equation such as just a plus b equals 3, here we have addition on the one side. So the opposite of addition is subtraction. Of course, so if we are adding on one side, then the opposite of that is subtraction. And of course, this goes backwards as well. If you have a subtraction, then it becomes an addition. So addition and subtraction are opposites. Other opposite operations that you'll see are multiplication, where we're multiplying things. And the opposite of multiplication is, of course, division. The other major math operation that you will quite often see in your high school science courses is taking the square of something, or squaring. So basically putting something to the second power. And so the opposite of this is taking the square root. And we'll see an example below where we use all of these operations. The second major rule that we see in this is that if you do something to one side, you must do it to the other side as well. So going back to our example here, if we have a plus b is equal to 3, and on the one side here we have a addition, so we're going to do the opposite of that. So we're going to subtract b on this one side. Well, we have to do it on the other side as well. So you see we've got minus b over here on the left, we've got minus b over here on the right. So we did the opposite operation on both sides. And so then the b's over here on the left are going to cancel out, and we are left with simply a is equal to 3 minus b. So let's now take a look at a couple of examples using some real equations that you see in high school science. So first of all, this formula here, v equals d over t, it shows how speed, distance, and time are related to each other. And in this case, we're asked to solve for d. So perhaps the question has told us what v is, it has told us what t is, and we want to know how long or how far something travels when it's going at a certain speed for a certain amount of time. So, and our formula is v equals d over t. And so how do we solve for d? Well, looking at our two rules from above, right now we have a division. So the opposite is multiplication. So we're trying to isolate d, so we want to get rid of the t. What are we doing? The opposite of division is multiplication, so we're going to multiply by t. And of course we have to do that on both sides. That's our second rule there. The t's over here on the right are going to cancel out, and we're left with v times t is equal to d. So that's a nice simple one, where we did the same thing on both sides to isolate for d. If we look at a slightly more complicated example here, we have this formula that Vf squared is equal to Vi squared plus 2AD. And this shows how an object moves when it's accelerating by relating its final velocity, which is Vf, its initial velocity, Vi, and its acceleration, A, and displacement, D. And we're asked to solve for Vi. So we want to get Vi all by itself. So this one is a little bit more complicated here. So the first thing that we're going to have to do here is right now the Vi squared is being added to 2AD, so we have to do the opposite of that. And we can move all of this at once. So we're adding all of 2AD, so we're going to want to subtract all of this 2AD. So of course we have to do it on both sides. So those are going to cancel out. And we are left with, on the left-hand side, we still have the Vf squared, we didn't change that, minus 2 times A times D. This is equal to Vi squared. And now here, we're almost finished. The Vi is almost isolated. It just has this squared. So remember, the opposite of squared is the square root. So we're going to take the square root of this side. And again, we have to do the opposite of that to the entire other side. And so if you remember the rules with square roots, you're going to have to do it to everything all at once. So the squared is going to cancel with the squared roots. I always like to cross things out so that I know I've done things right. So the square root of Vf squared minus 2AD is equal to Vi. So again here, we have successfully manipulated this formula to isolate the variable that we are looking for, which in this case was Vi. So a couple of quick examples there, and remember, every time we are manipulating formulas, it comes down to these two rules. To move something to the other side, just do the opposite math operation. Remember what the opposite math operations are, and if you do it to one side, you must do it to the other side as well. Okay, let's look at one more example here. So this formula here, Ek equals 1/2 mv squared. This relates the kinetic energy of a moving object, we'll just write Ek there, to its mass and its speed. And so if we want to solve for m, so say we'd been told what the kinetic energy of the object is, we know how fast it's going, and we want to figure out what its mass is. So again, we'll start by just writing out the formula, Ek equals 1/2 mv squared. And so we'll do this one in a couple of steps here. So we're trying to get the m all by itself. So the first thing let's do, let's get rid of this 1/2. So in order to get rid of this 1/2, this is basically we're dividing by 2. So the opposite of dividing by 2 is multiplying by 2. So we're going to multiply by 2 on both sides. 2 times 1/2 over here on the right. That cancels out, that just equals 1. So we are left with 2 times the kinetic energy, Ek, is equal to mv squared. Second step here. Right now we have mass is being multiplied by V squared. So the opposite of multiplying here is dividing. So we'll divide by V squared on both sides. Divide. Those cancel out. V squared divided by V squared again is just 1, so those cancel out. And we are left with the mass is equal to 2 times the kinetic energy divided by the speed squared. So again, just following all those two rules from above where you are doing the opposite operation on both